There once was this sweet couple. They were very happy, so they decided to get married. And for their honeymoon, they went to the most beautiful city in the whole wide world. They had a wonderful time. They enjoyed each other, but they also enjoyed the beautiful scenery. Streets filled with people, magnificent buildings and architecture, markets, shops, delightful restaurants and much, much more. So, they had incredibly rich percepts. They also experienced many qualia, ranging from the smell of croissants in the morning, the flow of the beautiful river that ran through the city, to the stunning sunsets in the evening. And at night, together, they experienced even more qualia they had never experienced before. They had read about it a lot and had heard other people's reports about these qualia, but finally experiencing these themselves made all the difference in the world. In short, they had a phenomenal experience. But then these evil scientists came along. "You silly couple," they said. "Don't get fooled by your seemingly rich percepts. Don't let these phenomenal experiences delude you. And don't you ever dare mention the word qualia again," the oldest and wisest of the evil scientists said. "Poor beings," they continued, "you suffer from an illusion of seeing. You may think that you have all these rich percepts. You may think that you see everything that is in front of your eyes, but in fact you don't." The couple was shocked. Why would these seemingly wise men say such evil things? Why would they want to rob them of these fabulous experiences? So they asked, "Dear scientists, do you have any experimental evidence to back up your ludicrous claims?" "Well, sure we have," the evil scientists countered. "Look at this array of objects. What do you see here, couple?" "Well, we see a circular array of 8 objects, of many colors, shapes and categories," the couple answered. "Ah, there you go," the scientist replied. "Not true, because we can show you the array, take it away, and after a brief interval show the array again. And if we then point to one of the objects and ask you whether that object had changed between the first and second array, you will hardly have a clue. You will suffer from change blindness. You will maybe perform slightly above chance, and we can convert that percentage correct in a number, indicating how many objects you really did see of the first array. And that number is very low. While you think you see all the 8 objects, at each moment in time you actually only take in about 2 of those items. This is our scientific proof that your conscious percepts are not rich at all. They are in fact very poor. You see, poor couple, this is why we say that you have an illusion of seeing. Of all the things around you, you only have access to what you attend to, and attention is very limited, so that you can only access and report a few items at a time. The illusion comes from that you can attend anything at any time, which makes you think you see everything. That's how it really works, you see. Now the couple got really depressed. What these wise men said made perfect sense. How could they have been so deluded? They decided to go home and lead a miserable, meaningless life, devoid of rich percepts, qualia and phenomenal experiences. But then these other scientists came along. They were the 3 musketeers of phenomenal experience. "Not so fast," they said. "Before you go home, take a look at this experiment. We show you the same array. Let it disappear during an interval and then show the changed array just like before. But now we present the cue during the interval. And then we present the second array and ask the same question. Was there a change or not?" "Wow," the couple said. "This time it's much easier." "Indeed," the musketeers replied. "When we now convert your percentage correct into a capacity, we find much higher numbers, almost as high as the size of the array. This shows you something very important. Apparently, after the first array has disappeared, you still have a representation of all or almost all of these objects in your mind. And the cue then allows you to retrieve an item from that representation and then compare it to the item in the second array. Now normally, this second array overrides the representation of the first array. That is why you suffer from change blindness. But this version of the experiment shows you that when the first array is on, and even after it had disappeared, you have in fact a very rich representation of that whole array in your mind. To be a bit more precise, the Musketeer scientist explained, what this shows is that you have two representations in your head of the array of objects. There is this representation that depends on attention, and this is what you have access to. Hence it is stable and not so easily overwritten. But its drawback is that it has limited capacity. At the same time, however, you have this much richer representation of many more objects. That is, however, very fragile. It gets overwritten as soon as a new array of objects is presented. These two representations are very much linked to what other people have called working memory and iconic memory. How do you know all this? The couple asked. So the Musketeer scientists continued by showing further experiments they had performed. We know that the limited capacity store is related to attention and access because when we disrupt the dorsolateral prefrontal cortex with TMS pulses during the task, we see a decline in the working memory capacity, here in red without TMS and in pink with TMS, but not in the fragile memory capacity, both in blue. In another experiment, subjects had to do a simultaneous n-back task with letters presented at the fixation point, while arrays of rectangles were shown every now and then, on which they had to do a change detection task with early and late cues, as we showed you before. Now, the attention-demanding n-back task had an influence on the working memory capacity, but not on the fragile memory capacity. So these results show that while the working memory capacity depends on frontal cortex and attention, the fragile memory capacity is independent of frontal cortex and attention. So where does the fragile representation then sit, the couple asked? The fragile representation depends on visual cortex, the scientists replied. For example, fragile capacities differ between subjects, and this seems to depend on the size of visual cortex of that subject. The larger your V1, V2 and V3, the larger your fragile capacity is. Also, the amount of glutamate in your visual cortex relates to your fragile or iconic memory capacity, while this has no effect on your working memory capacity. And finally, we are even able to manipulate your fragile or iconic memory capacity by applying a small current to your visual cortex using what is called transcranial direct current stimulation, or tDCS. Depending on the direction of the current flow, we can either increase or decrease your fragile memory capacity. So, you see, these two different memory capacities, these two different representations in your head, they are very different neural substrates. And they depend differently on access and attention. The limited capacity store depends on attention, access and the frontal cortex. The large capacity store is independent of attention and resides in visual cortex, which also explains why it gets overwritten with every new visual scene you present. By the way, please note that although these are types of memory that we study here, they are relevant for the research of conscious experience. The two forms are in fact remnants of what you experienced while the stimuli was still there. So also while you look at the array, you have two representations, a fleeting and fragile, yet rich representation of stuff you do not attend at this moment, and a more stable, cognitive and accessed but more limited representation of stuff you do attend. So in conclusion, the more thoughtful of the Musketeers summarized, we think there is ample evidence to support your intuitive idea of a rich percept. You do have a rich representation in your heads. So it could very well be that you also have a rich conscious experience. The only problem is that you cannot access and report all that information because of this attentional bottleneck. Your phenomenal experience overflows access and report. The couple felt a great sense of relief from what the Musketeer scientists had told them. Could it be that they were right after all, that indeed they had these phenomenal experiences, but simply couldn't access and report all of them? Not so fast, the evil scientist replied. This sounds all very attractive, but is it really true? This so-called high-capacity representation, what is that really? To us, it sounds like nothing more than just a gist of the scene, So the vague notion that there are 8 objects out there without you really knowing what they are. We have reasons to believe that the objects in that so-called rich representation of you are in fact degraded, lacking any detail, precision and grouping. So not really conscious, but only pre-conscious objects at best, that only become conscious once you access them. Now the couple started to doubt again. Yes, how could they ever know whether all these unattended objects were as clearly visible as the attended ones? That is not so difficult, the musketeer scientist replied. It is in fact an empirical issue. Indeed, if these objects are degraded, we should retract our claims. But when on the other hand we can show that items in the large capacity representation are just as good as the attended ones, well then our position gains in credibility. So the musketeer scientists did many more experiments. They did that change detection experiment again, but now, after every trial, they asked subjects not only to indicate whether there was a change or not, but also to indicate what the item was that was present in the array before the change occurred, by choosing among 4 different potential pre-change objects. If the pre-change item was identified correctly, the detection would count as a high-quality object. If, however, the pre-change item was misidentified, this would count as a low-quality object. And in this way they could, for each store, calculate the number of high and low quality objects it held. They found that the low capacity working memory store held about 2 items as before, one of which was low quality and one of which was high quality. And much to their surprise, they found that the fragile and iconic memory stores also held about 1 low quality object, but that all the rest, so 4 to 6 objects, were in fact high-quality objects. Thus, they concluded that, in contrast to the allegations of the evil scientist, the items in the large capacity representation were not just a mere gist, but held items in great detail. In another experiment, they had subjects rotate arrows back to their original orientation after a similar change detection paradigm. This showed that the working and fragile memory stores had in fact exactly equal precisions. So also from that perspective, the evil scientist's claim was falsified. And in a third experiment, they showed some very important additional property of the high-capacity store. They used arrays of Pac-Man in a change detection task that were either arranged such that Canissa, illusory triangles, were visible or not. With the Canissa triangles visible, the task was much easier, because now each of the 4 Pac-Men could be reduced to a single item, an arrow pointing either in or outwards relative to the fixation point. With the Canissa triangles absent, the memory load was much larger, because each Pac-Man had to be stored individually. Indeed, this had a huge effect on performance. In the Canissa condition, performance, and hence capacity, was much higher than in the non-condition control condition. But importantly, this benefit was equally present, or even larger, for the fragile and iconic memory conditions than for the working memory condition. This showed a very important point. It showed that phenomenal properties like grouping and the formation of illusory contours and shapes was equally present in the large capacity representation as it was in the low capacity representation. So in conclusion, these experiments showed that the assumption that the evil scientist had made was false. The large capacity representation was not just a mere gist, some vague pre-conscious objects that would hardly qualify as really conscious. If that would have been the case, indeed the notion of a rich percept would have been falsified. But the opposite turned out to be the case. The large capacity store was not only rich, but also held items in great detail and precision, and also in full perceptual form, as items were grouped to form illusory shapes. The couple were impressed, but still also had doubts. Couldn't you guys throw in some neural arguments and data? Somehow that always seems more convincing to us, they said. Sure we can, the musketeer scientist continued. What do you prefer, data from animal or human research? Well, a bit of both would be fine, the couple replied. Well, here's some animal stuff, already from quite a while ago actually. We recorded from primary visual cortex in monkeys that were looking at textured figure ground stimuli, like shown here. We found that when the neuron's receptive field was on the figure region, its response would be higher than when it was on the background region, even if we used the same line orientations for both. This increased activity was shown to depend on recurrent signals from higher visual cortex back to V1, which occurs at a latency of about 100 milliseconds in these animals. Now here's a special thing about these recurrent signals. It appeared that they only occurred in the awake state. In anesthetized animals, the neurons still respond to the line segments that make up the textures, but the recurrent signals are selectively absent. And you know what? These signals are similarly absent when the monkeys do not see the figures, when they fail to distinguish figure from background on specific trials. So on the one hand, we have a pretty interesting signal here that seems to reflect recurrent processing related to the integration of line segments into coherent figures, and that is only present in the awake condition and when monkeys see the figures. Yet on the other hand, we show that these signals do not depend on attention. In this experiment, for example, we found that the recurrent processing signals are equally large whether the monkey has to divide his attention over 1, 2 or 4 figures. If the recurrent signals would depend on attention, you would expect them to go down with increasing numbers of figures, but they didn't, indicating that they are independent of attention. In another experiment, we independently manipulated visibility of the figures and the decision criterion of the monkey to report the figures. The visibility was manipulated by using different lengths of line segments, and the decision criterion was manipulated by using different amounts of catch trials, where no figure was present. Well, if you want to look up the details, I can highly recommend you look at the paper by Super et al. Anyhow, what we found was that the recurrent signals on the one hand reflected visibility and the detection of these figures, but on the other hand were completely independent of the monkey's decision to report the figure. So that was more evidence in favor of a dissociation between perceptually related recurrent signals and the report of the stimuli that evoked these signals. In humans we found the same thing. We recorded EEG while subjects were doing an intentionally demanding task with letters at fixation, and meanwhile we presented figure ground stimuli in the surround. Many subjects failed to notice these figures and were not able to report them afterwards, but regardless, their brains signaled the presence or absence of these figures. The EEG signal was even exactly the same for figures that were noticed and reported as they were for figures that were not noticed and reported. Also in humans we recorded fMRI responses to kinesia stimuli. Now the kinesia stimulus is interesting because it requires the perceptual grouping of the inducing Pac-Man into a coherent figure, a pentagon in this case. Moreover, in the kinesia you have what is called perceptual inference. You see an illusory contour that's not really there, and you see an illusory brightness increase that's also not really there. You infer those from the stimulus. Other research has shown that the kinesia stimulus depends on recurrent interactions between areas V1, V2 and area LO, and that you don't see the illusory figure when it is masked. So we use the kinesia pentagon in an inattention paradigm together with 3 control stimuli where you also have inducers but without the real illusion, without the perceptual inference. Again, subjects were doing a foveal task involving letters, and many did not notice the kinesia configuration that was surrounding these letters. But regardless, the kinesia specific signals, here in orange, were equally strong whether the kinesia was noticed and reported or not. So these neural results add an important point. They show you that even without any attention, access and reportability, your brain still integrates features into meaningful perceptual representations. It does so via these recurrent interactions that integrate information from several layers of the visual hierarchy, so that low-level signals about simple features are combined with high-level signals about more complex features. The couple were jumping for joy. "Yippee," they said, "so that clearly is solid evidence that we have rich representations that look just like attended and reported ones, even if we cannot attend or report them." But the evil scientists were not about to give in that quickly. "All very well," they said, "but listen, do you realize that when stuff is not attended or accessed, it does not enter the global workspace?" Now, this was new to the couple. The global workspace. That sounded important. "So what does that bring us, the global workspace?" they asked. "Well, it gives you global ignition, which makes the information available for cognition. It makes it available for processing by other modules in your brain, which gives you access and report, which in turn renders it conscious. Well, that sounded a bit circular to the couple, but nevertheless making some sense at the same time. But either way, the couple was now getting quite confused. So here they were, with these two groups of scientists. The evil scientists who claim that only when information enters the global workspace, this gives you access and reportability, and hence consciousness of that information. And then there were the musketeers of phenomenal experience, who claim that even without access, you still have localized recurrent processing, which gives you perceptual integration and hence conscious experience. Who was right? The couple decided it was time to do some thinking of their own. So they took a course in the philosophy of science and started to think things over. What would make most scientific sense, they asked themselves. Well, in difficult issues it's always good to start with some certainties, so which were those? It seemed that all of the scientists agreed on these basics. Visual processing seemed to progress in 3 stages. At first you had the activation of all sorts of modules that detected features or even objects such as faces. But as long as the information progressed through the visual system in a feed-forward sense, these modules worked independently. All these features would be detected in isolation so that they would remain unbound. Then these recurrent interactions started, where the modules would interact, so that you got the integration of information and things like perceptual inference. And then finally, the interactions would grow even more widespread and involve areas in the more executive regions of the brain, which gave you attention, access and reportability, which was the global ignition they talked about. What the scientists also seemed to agree about was the phenomenal character of the 2 extreme states. The stage where you only had isolated feature detection clearly was unconscious. This was shown by many masking experiments and much more. Even if the only task of the subject was to report a mask stimulus, they could not do that, so why doubt the absence of conscious experience there? The other extreme, where you had the global ignition, was clearly conscious. People reported what they were seeing, so, why doubt that? The only thing the scientists seemed to disagree on was this middle ground, where to put the unconscious-conscious divide. At the transition between stage 2 and 3, or at the transition between stages 1 and 2. The only way to settle this debate would be to weigh the scientific pros and cons of putting the divide either early or late. So that's what the couple decided to do. What would be the real benefit, they asked, of putting the divide late, as the evil scientists argued? This would make the middle stage unconscious and hence put all the explanatory burden of explaining consciousness on this 3rd stage. They thought about it a lot, but they simply didn't get it. They just couldn't see what this would bring towards a better understanding of consciousness. Why would access make stuff conscious? They did explain the access, sure, and the reportability, which relies on the involvement of more executive models of the brain. But did it explain why conscious visual sensations look the way they do? Did it explain why conscious experience is this integrated whole of parts? It did not explain that at all, actually. So from that perspective, it didn't really advance their understanding of consciousness. Then there was this other problem. The couple learned that there were now many experiments that had shown that you could get unconscious activation of the global workspace neurons, so the neurons in the frontal regions of the brain, that were involved in things like cognitive control, attention or working memory. Even when stimuli are heavily masked, these stimuli can reach the global workspace and yet not be consciously perceived. This seemed inconsistent with the idea that global workspace neurons have a special role in generating conscious experience. So then the couple looked at the other option, putting the divide between stages 1 and 2. That would make the middle stage conscious and hence put all the explanatory burden on this middle stage. Or in other words, put the explanatory burden on the difference between isolated modules doing their jobs, stage 1, versus recurrent interactions integrating the information between these modules, stage 2. Actually, this made quite some sense. A key feature of conscious experience is its integrated nature. take seeing a face. Consciously seeing a face is not just categorizing the stimulus as being a face or recognizing that it is, say, John's face. It is integrating the faceness with its shape, its color, the way the eyes look at you, the emotional expression, and many more things all at once. Integrating these features is what makes the difference between conscious perception and unconscious categorization. So putting the boundary between stages 1 and 2 clearly gave much more explanatory power in understanding why conscious sensations look the way they do. And while the couple was thinking that, suddenly this other scientist appeared. He agreed. Indeed, integrated information is the key to understanding consciousness, he argued. Then he continued with some formulas that were way too complex for the couple to understand, but which gave them the feeling that their choice was right. Also, they noticed that by putting the divide between feed-forward and recurrent processing, they lay the divide at the most dramatic and fundamental of the differences between the three stages. As they had seen, there were in fact no fundamental differences between stages 2 and 3. Much of the same things go on, in that information from separate modules gets integrated. The number of modules that interact increases from stage 2 and 3, so the difference is merely quantitative. The more fundamental transition seemed between stages 1 and 2, where you go from no interaction to interaction. So laying the divide there made much more taxonomic sense. Of course, laying the divide between feed-forward and recurrent processing was causing a problem. Wouldn't that imply that any being with the least bit amount of recurrent processing would be conscious? Or that even a piece of brain in a petri dish would be conscious as long as it would engage in recurrent interactions? Well, that could very well be. But many theories of consciousness have that property, the propensity to cause panpsychism, the notion that consciousness is present in even the lowest forms of beings, maybe up to simple machines. But who were they, the happy couple, to deny consciousness to other beings? Maybe indeed simple animals or even insects and iPhones have consciousness. Their consciousness would be different, of course, from theirs, but consciousness it would be. And then this other scientist appeared, who seemed to agree, which made the couple more confident again that they made the right choice. Finally, they noticed something else. If you say that attention or access is consciousness, as the evil scientists seem to imply, then you simply equate consciousness to these cognitive functions. What would be the point then to talk about consciousness? If consciousness is cognition, is attention, or is access, why would you give it a different and confusing name? Why would you study it at all? Why would you not go on study these cognitive functions without ever worrying about consciousness? By laying the divide between stages 1 and 2, however, you give consciousness an independent role. Consciousness now is something that precedes cognition. Consciousness now is something that has its own and proper ontological status. And then this third scientist emerged, confirming their view. Indeed, he said, there are now many results arguing for the independence of attention and consciousness. So the couple had decided. They had made that choice. By looking at the scientific benefits of each of the two positions, it became clear which was the better option. It became clear that consciousness is much better explained, is more clearly taxonomized and given a more proper ontological status by going with what the musketeers of phenomenal experience had said. That gave them all the confidence to drop the position of the evil scientists. It simply made no sense, they concluded, even though it seemed to do so for a while. The couple was happy again. They realized that the story of the evil scientist was just a nightmare. Their honeymoon did consist of rich percepts. They did have these wonderful qualia, and they really had enjoyed these phenomenal experiences. Nobody could take that away from them anymore. Of course, they wanted to thank the musketeers of phenomenal experience for this magnificent ending. But the musketeers said, "You're welcome, but don't thank us. Thank all the people who did the real work."